Okay, so my name is Jeremy Chua, and I'm working with Timothy. So now I'll be talking about how we get the solution for our HBR worksheet. So starting, we were given this cosine half x and x equals to pi. So according to the worksheet, we need to find the Taylor series. So first I do f x equals to cosine half x. So I find what is the value. So I sub in the pi equals to 0. After that, we need to this is the first one. So the second one is f x. So for this, you need to differentiate cosine. Differentiate cosine half x, you get negative half sine x. Okay, so we need to find the value is sub in the pi into this, sub in pi into this equation, you'll get negative half. After that, you take f1, so you differentiate one more time, cause you need to find the they say need to find fourth term of it. So you just differentiate this one again, negative 4 cosine half x. Okay, then the same thing, you just pi it. Sub in pi equals to this equation, you get 0. Okay, so after that, you 1, 2, 3, so we need to do one more. X equals, so we need to differentiate this now. Differentiate this, you get 8 sine half x. Oh yeah, so sidetrack a bit, I backtrack a bit. So negative half, when you want to differentiate this, right, it became negative because differentiate sine, you get cosine again, so it bring over the negative. Then after that, you time half, you will get 1 over 4. So for the same is here, 1 over 4 you time half, you get 1 over 8. Yeah, so it's the same thing. Sub in pi into this equation again, you get 1 over 8. So this is how I get the first 4 term, 1, 2, 3, 4. And this was my original, what I was given. So this is the Taylor series. So now we need to write the Taylor series out. Okay, so the Taylor series out, right, just write cosine half x like this equals to, so according to the formula, right, the first you need to write this 0 first. So 0 first. After that, according to the formula again, is negative half followed by negative half. After that, the formula minus pi. After that, you plus this one, this is the second one, 0 to x minus pi square. Then you plus this one, 1 over 8 over 3. Okay, so you can see, right, this is 2 exclamation mark and 3 exclamation mark. So you type this in the calculator and type this in the calculator, it will give you negative half x plus half pi plus 1 over 48. Okay, how I get this is, for this I open up. After that, this I found that equivalent to 0, so 0 times anything is 0, so that this one cancel off. And for this is, you attend calculator, I will get this, and just write here, copy. After that, then I put this in the graph, the website in the graph. Then the first answer is do the graph look exactly the same? Why do they look the same? I write no. Both graph intersect between the point 2 and 4 of the for the x-axis. So it doesn't look the same because of the lack of Taylor series. They need to do more Taylor series term in order to become more similar. Then the similarity between the both graphs is that they intersect 2 and 4 of the x-axis, which I discovered when I put in the equation at the website given. So for the second question, they say what do you make to look the more similar? I just say do more terms for the Taylor series. Yeah, so this is the end for my part. Next we'll be passing on to Timothy, who will be talking more about all of this and all the way to the end of the worksheet. Thank you.
Hello, this is Timothy, continuing on from Jeremy's explanation. So for the question, they asked to add more terms in the Taylor series. So I'll be adding on 4 more terms. We'll be adding the 4th derivative, 5th, 6th, and 7th derivative. So from 1 over 8 sine bracket 1/2 x, we will be differentiating sine will give us cosine, and the whatever outside will be multiplied by the half over inside the bracket. So 1 over 8 multiplied by 1 over half give us 1 over 16 over here, and the value inside doesn't change. Then for the 4th derivative, when x is equal to pi, the function value will be 0. Then when for the 5th derivative of x, from as explained earlier on, cosine will become sine, and there will be a negative when cosine is differentiated. So when cosine is differentiated, it gives us negative sine. Then the value inside will stay the same, but the half will be multiplied by 1 over 16, which gives us 1 over 32. The value of this function, the a value of this function when x is equal to pi, gives us negative 1 over 32 if you press it on the calculator. Then the 6th term is the same. Sine differentiator gives us cosine. The sign never change. The whatever inside the bracket remains the same, and whatever is outside will be multiplied by the half, which gives us negative 1 over 64. The a value of this function of the 6th derivative is 0. Then for the 7th derivative, from cosine we will again change to sine, so it will be negative again, negative cosine. But since there's already a negative here, it cancels out, so it becomes a positive number. And 1 over half stays the same, multiplied by 1 over 64 give us 1 over 128. And the function of this derivative is the a value of this 7th derivative is 1 over 128 when pressed in the calculator, and x is equal to pi. From what we can get, the 4th term will be 0 over 4 factorial bracket x minus pi to the power 4 minus 1 over 2 fifth factorial. This is the a value, which can be seen from here, and to the power of 5 minus 0 over 6 factorial bracket x minus pi to the power of 6. Then for the seventh term is 1 over 128 to the 7 factorial bracket x minus pi to the power of 7. Then from here we can say that this whole thing, 0 over 4 factorial gives us 0. So 0 multiplied by whatever is in this bracket will give us still 0. Then from here, 1 over 32 to the power over 5 factorial give us 1 over 3840. Then this one bring here is bracket x to x minus pi to the power of 5 minus 0 plus 1. This is 0 because the sixth term is also 0, the numerator. So 0 over 6 factorial gives us 0, and it just cancels out whatever's here. So for the seventh term is 1 over 645,120. Since 1 over 128 over 7 factorial gives us this number. Then bracket x minus pi bracket to the power 7. Then putting the other terms that I've obtained from for the series brings us to the graph. So for the graph, this is what Jeremy has. So for the graph here, this is the graph that we were asked to place in, and this is what Jeremy has placed inside the graph for the first few derivatives. So showing only the cosine graph, the y is equal to cosine half bracket half x. This is what the graph shows. Then adding what Jeremy has found from the derivative for the first three derivatives. This is the graph. The graph, if you zoom in, it's the same for from 2 to 4, this part of x. Then when I add 4 more derivatives for the graph, the black line shows the one that has been added more terms, is over here. See, I didn't put the 4th and 6th one since they are 0 and they are irrelevant. So as for this part. So as we can see here, the graph, the black line is more aligned to the y is equal to cos bracket 0.5x. So for the question, what conclusion can you make about the approximate fraction of using Taylor's series? From the graph that I showed earlier, we can say that by adding more function of x, derivative of x, the graph will look more accurate. Then for the next question, the tree graph seems to be exactly intersecting at x is equal to pi. Why do you think that is the case? The answer is, it is because like the value of x that we use is pi. Therefore all three graphs will seem to be intersecting at will be merging at pi. That's it for our project. Thank you for listening and giving the patience to watch the entire video.